Welcome to PMA channel. In my last lecture, we have just gone through the one part that is, we have studied the antennas, and before that, we have studied, you can say, uh, various coding schemes, and before that, we have gone through the basic elements like digital and analog signal, and then basics of, you can say, communication. Now, we have landed to one very important question. From previous topic, two questions can be asked. You may be given the wavelength. You will have to calculate the length of antenna first in case of Marconi antenna, which is 1/4 of the wavelength of the wave to be radiated, and then it may be asked in case of Hertz antenna and lambda by 2. And for just to recall the previous lecture, in previous lecture, first is Hertz antenna. The length of the Hertz antenna, I will write it by LH. LH is just lambda by 2. It is not grounded. And then in case of Marconi antenna, this is lambda by 4. Again, remember, it is grounded. And this was about the length of the antenna, which is very much important because we have to go through the process of transportation, installation, and manufacturing. These three processes, if the length is small, then these three processes, they can be easily dealt with. Another important factor, which is core factor, is that power. We need more and more power. If more power is transmitted, then the signal can go up to greater length without much of the attenuation, and we will be needing less repeaters. If less repeaters means less cost of transmission. Now in this case, I will explore the issue of modulation. Why modulation is necessary? Because of this very fact, because length is 1/2 or 1/4 of the wavelength of the radiation to be transmitted. Now we will quickly uh, go through this topic. First is a massive signal usually spread over a range of frequency. The range of frequency over which a massive signal is spread is called signal bandwidth or the baseband signal. Even now, I will just give you the concept. You have to give some space. For example, I will show by line. Let this range of frequency be the this straight line indicates the range of frequencies or the signal bandwidth. When we have to divide the bandwidth of the communication channel, in addition to this signal bandwidth, we have to keep some blank spaces here so as to avoid the interference between between signal bandwidths of different signals. Remember this line. So once a question was asked, for example, you are given bandwidth and then you divide it by channel bandwidth. You are given channel bandwidth. You divide the channel bandwidth with the base band of the signal. Then you get a particular number, and that will be the number of channels. We have just done this calculation in my previous lecture. Actual number of channel will be slightly lesser than the number of channel that we have calculated by going through this way of calculation which I have just outlined. Now, here particularly, we can transmit electrical signal in audio. Audio range of frequencies 20 Hz to 20 kHz. Now, antenna for making audio signal transmission is next to impossible. How? Minimum length of the antenna is in case of Marconi antenna, which is lambda by 4. Now, suppose the frequency is 10 kilohertz. This is the frequency of 10 kilohertz. Now, we will divide here. Lambda is, you can say, velocity of light or the speed of light divided by frequency. Frequency is 10 kilohertz, 10 raised to power 4. Note it down here, 10 raised to power 4. 3 into 10 raised to power 8 is the speed of light. And we got this 30,000 meter long. 30,000 meter is the wavelength. Now we will divide it by, you can say, 4. We will get 7,500 meter means 7.5 kilometer antenna. Definitely impractical. We need 7.5 kilometer antenna in length, which is very large. How we will manufacture such a long antenna, and how we will carry it, and then how we will install it on the top of a building? It is not possible. Just imagine 7.5 kilometer antenna is to be installed on your building. It is absolutely impracticable. Now suppose if I increase this, you can say from 10 we go to the 20 kilohertz. Even if I divide it by 200, if I divide it by 200, then its length will be 30, about 34 to 30, 37 meters. 37 meters, you just 100 feet. 100 feet means the length of the antenna will be up to a 10-story building. It is again impractical. Now, what the lesson that we want to learn is here, simply you cannot make an antenna to transmit audio frequency range. You cannot make an antenna which can be practically useful for audio range frequency. Now, we want to decrease the wavelength. We have to increase the frequency. Now, process of modulation is used up. And here we have given a table. If the frequency is 10 kilohertz, we need 7500 meter antenna, 20 kilohertz, 3750, 30, 2500, and 1 megahertz, 75 meter. Now this clearly tells us we need low frequency, we need to convert this low frequency signal. I will write it as low frequency, L for low, F for frequency, S for signal. We want to convert this low frequency signal into high frequency signal. Now, if we have to convert this low frequency signal to high frequency signal, the process that comes into picture is modulation. I am writing it just by MODU. By process of modulation, we convert a low frequency signal into a high frequency signal. Now this high frequency signal will be having less wavelength, smaller wavelength. Smaller wavelength means smaller antenna size. Above all, note it down this. If wavelength is small, then power goes up. The modulation process is performed to decrease the length of antenna and to increase the power of the signal to be transmitted. Both these factors, they reduce the cost. And now, effective power radiated. This is an important issue that I will have to take up. Effective power radiated. Power P radiated from a linear antenna of length L is proportional to 1 by lambda square. We have already seen the relationship that P is equal to D divided by lambda square, or I can say that P is inversely proportional to lambda square. Or this implies another thing. P is directly proportional to frequency. This is nu square. It is directly proportional to nu square. So it means higher frequency, higher is the power radiated. Now we have to mix up the signal. We have to mix up a low frequency signal with a high frequency signal. That mixing up is known as modulation. Mixing up signal. When many people are talking at the same time, signals get mixed. There is no way to differentiate it. The possible solution of communication at high frequency is allotting a band of frequencies to each transmitter so there is no mixing. Baseband, band of frequency you just out of the communication channel which is expected to have very large bandwidth, you just divide that large bandwidth into a huge number of pieces so that different signals can be transmitted through the same communication channel. Now, what is modulation? Modulation, it is the phenomena of superimposing low audio frequency base band masses or information signal onto a high frequency carrier wave. Carrier wave is the wave which carries, and what carrier wave carries is the information signal. Information signal is low frequency and high wavelength signal. So this low frequency signal is carried by a carrier wave which is a high frequency signal. So the result is the wave that is called modulated wave. Now we shall be using a terminology. One is modulated wave, other is modulating wave. So these three are four different kinds of, you can say, terminology we will be making use. Now there is one more logic. Now remember, a simple sinusoidal wave, it has got some characteristics or parameters. One is amplitude. If we vary the amplitude, I will write it by A. If we vary the amplitude of carrier wave with respect to information signal, I will write it by IS. IS is information signal. If you vary amplitude of the carrier wave with respect to the information signal, then we got amplitude modulation. If you vary frequency of the carrier wave, then we get frequency modulation. Here I will write frequency. This is frequency modulation. And these two modulations, they are very important. Amplitude modulation is easy to do, but the signal in this modulation, the quality of signal is poor. In case of amplitude modulation, again amplitude of the carrier wave is varied with respect to information signal. Amplitude modulation has got low quality. Its quality is low, but it is easy. It is easy and it is of low quality. But on the same line, frequency modulation in this case, quality is very high, but cost of circuit also, it is not easy to prepare the circuit. You just focus on quality. In amplitude modulation, quality is low. In frequency modulation, quality is high. Particularly the radio channels that you listen in your cars, FM band, they use frequency modulation. You will have heard FM band. FM band means band or radio station which uses frequency modulation for transmitting the signal. AM. These two terms, they are very much popular in radio transmission. One is AM. Frequency is this and this AM. And thus, when they use the word AM, it means they are making use of amplitude modulation. And when they make use of frequency this and this FM, then they are making use of frequency modulation. In amplitude modulation, again, it is the amplitude of the carrier wave that is changed. Amplitude of carrier wave is changed in case of amplitude modulation. In case of frequency modulation, frequency of the carrier is changed. With respect to what? With respect to the information signal. With respect to the information signal. Processes in amplitude modulation, we vary the amplitude of the carrier wave with respect to this information signal. In case of frequency modulation, we vary the frequency of the carrier wave with respect to what? With respect to the information signal. Now, there were three characteristics of a continuous curve or continuous sinusoidal wave. One is amplitude, other is frequency, and third is time. Time and frequency is same, or these two. Another is phase. Phase, I won't go into the phase because that is used very rarely. Absolutely not used. Only two are used. One is amplitude and frequency. Now, this is a continuous curve or an analog curve. Now, there is digital modulation. Note down, there is digital modulation. In this case, we have got a signal like this. It is a square wave. One is pulse duration. Pulse duration modulation, PD, PDM, and then PAM, pulse amplitude modulation, pulse duration modulation, PDM, and then pulse amplitude modulation, and then pulse frequency modulation, and then you can say pulse width modulation. Another is pulse width modulation. There are about 3 to 4 kinds of modulation. But fortunately, you are only concerned with this. This you will pulse shape signal, or you can say digital modulation, you will study in your electronics engineering. Now the next topic is types of modulation, which I shall be taking up in my next lecture.